So, welcome back. Here, we are going to discuss the architecture of TMS 320 C67XX DSP processor. This processor is made by Texas Instruments and is used to process the digital signals. The architecture part can mainly classified or mainly divided into four parts. The first part is the CPU, that is the central processing unit, and this part constitutes the, the CPU. And the next is memories, and it has two memories since this follow Harvard architecture. So separate memories for data memory as well as the program memory. And next is the DMA bar EMIF, that is the direct memory access and external memory interface. And the last section goes to the additional peripherals for the timers, serial ports, memories, etc. So coming to the CPU, it is denoted by C6000 CPU, which means that it is common to all the C6000 family. This processor is used for 6200, 6200, 6400, 6435, 64 XX, and 6700, 6713, like that. Here, there is a power down logic. This power down logic is used to reduce the power of the DSP. So, some power saving mode is active. This power down module get activated, and the CPU controls all the processing. The processing is done in a sequential order, that is program fetch, instruction dispatch, and instruction decode. The instructions are taken from the program memory, and the data are taken from the data memory. Here we have two data paths, data path A and data path B. Data path A consists of a register file A. Similarly, data path B consists of a register file B. Each data registers, that is data register A as well as the data register B, has 16 registers. So there is a total of 32 registers in the CPU. So when we fetch, dispatch and decode the data as well as the programs, we have to process that data. To process that data, we have four functional units denoted by .L, .S, .M and .D, each for each registers. So the register file A has .L1, .S1, .M1 and .D1. Similarly, the register file B having .D2, .M2, .S2 and .L2. The .L1, .S1 and .D1 is used for the arithmetic and logical operations, for the register file A. Similarly, for the register file B, the arithmetic and logical operations are done by .L2, .S2 and .D2. So there is a total 6 functional units for the arithmetic and logical functions. And remaining two functional units that are .M1 and .M2 are used as the multipliers. For controlling the CPU, we have control registers, control logics, testing, emulation, and interrupts. So the control registers include flag register, sign bit register, like that. And coming to the memory, there is a program memory as well as a data memory. These memory can act as cache cache memory also. So the fast processing can be done using these registers. Both the registers having 32-bit address lines. The program register have 256-bit data, and the data register data memory have variable bit data like 8, 16, 32 like this. One of the special feature in the TMS 320 C67XS is the DMA. So normally um, if we have a memory here, there is a register and one CPU. To access this memory by this register, we cannot directly go and take the contents from the memory by the register. So here the register asks the CPU, and then the CPU will give the permission to access the memory. So when that memory access is involved, using this direct memory access, the register can access the memory without asking the CPU, asking the permission of the CPU. This access is controlled by the DMA controller, that is the direct memory access controller. So in this figure, without there is no line between the DMA and the this CPU. Okay, so using this um, um, so using this, we can directly access the contents from the program memory as well as the data memory. So next is external memory interface. So external memory interface is the another feature of this architecture. In this, we can access the external memory like SD RAM, SB RAM, DRAM, such memories with the help of this EMIF. This okay, thank you. One more thing, we have other features like hot port interface,